microorganism is used. So let's hear the presentation. Please welcome him with a big round of applause. Thank you very much for that introduction. First, I would like to say that I am very grateful to Mr. Kim of KIOST, President Kim of KIOST, for organizing this special session and inviting me as a speaker. As introduced by our moderator, today I want to deliver a presentation on how we can develop biohydrogen production technology using microorganism from deep-sea hydrothermal vents. First, as you might already know, in the case of the Republic of Korea, we are relying 93% of energy on imports. We rank number 9 in the world when it comes to the amount of energy consumption. And we are also relying heavily on fossil fuels, and this is leading to many challenges such as climate change and energy shortage and so on. To respond to these challenges, the Korean government is constantly receiving requests to achieve carbon neutrality, and it is making a lot of effort to meet that goal of carbon neutrality. It is trying to increase the portion of renewable energy in the total energy mix, and the government is also investing a lot to increase research on new and renewable energy sources. In 2019, Korea already announced the vision to realize the hydrogen economy, and this is contained in the hydrogen economy roadmap of the Korean government. And the plan is to become the #1 country in terms of hydrogen and hydrogen fuel cell industry. But still, there are a few remaining challenges in the hydrogen industry. First, in terms of production, we are producing about 1.9 million tons of hydrogen like this. And most of the hydrogen is used in the refinery process, and about 260,000 tons are distributed in the market. However, one more challenge is that 95% of the hydrogen produced is based on fossil fuels, such as oil. So in the long term, we need to be able to utilize new and renewable energy sources like winds and water in producing hydrogen. So we are in a situation where we need to think of these new technologies. So using microorganism to produce biohydrogen is another option, which is an eco-friendly way, and this is receiving a lot of interest across the world, and many scholars are also conducting research to make this a reality. However, at the moment, this is a technology that is yet to be commercialized. So KIOST also conducted a research on this topic, and we focused on the potential of microorganisms in deep sea. According to census reports, there are about 20 million species of microorganism under the sea. So despite this diversity of species in undersea, and across the world, the diversity of microorganism is expected to be far greater, with more than 1 trillion species. So we began to think that we can find solution from this diversity of microorganism under the water. So we started to focus on this, and we have been developing technologies to use these microorganisms to develop biohydrogen. So today I want to talk about this microorganism called Na1, Thermococcus onureneus Na1. In 2002, with KIOST's own technology, we were able to discover this microorganism, which is a hyperthermatic archaea that we discovered using the ship named Onnuri, and that is why we named this microorganism as Onnuri News, and it looks like this, like a small ball. Back then, when we first discovered and classified this microorganism, we didn't think that we will be able to produce biohydrogen using this Na1, but we thought that we will be able to utilize this hyperthermatic archaea in different ways, and we analyzed this genomic sequence of Na1. And as we analyzed this sequence, we were able to discover that there are 7 different hydrogenases in this Na1. And 5% of this Na1's genome information was related to hydrogen. And in 2008, we were able to discover this fact, and it was a very interesting discovery. So based on this discovery, we continued to conduct research on this hydrogenase, a key enzyme involved in the metabolism of hydrogen. And we were able to also discover a phenomenon that we titled energy minimalism. And we are continuing to publish follow-up articles on this topic. So in this process, we realized that probably using this microorganism, we can come up with a technology to produce biohydrogen. In order to produce biohydrogen, we need to first secure a source or a raw material that can be used as a feedstock. And we discovered that in the production of biohydrogen using Na1, we need carbon monoxide, and there are lots of byproduct waste gas containing carbon monoxide like this. For example, the byproduct gas coming out from BFG contains 20% carbon monoxide like this. So we thought that if we can utilize the byproduct gas coming from steel mills like this as a raw material, we will be able to create biohydrogen that is economically feasible and affordable. So we came up with this production diagram where we use byproduct gas as a raw material, and we go through the microbial gas fermentation process, and then hydrogen separation, and then storage. In 2010, when we were conducting this research, this technology was unprecedented. Back then, we were working together with researchers in Dangjin Steel Mill. So we brought the byproduct gas to Ansan's KIOST campus and developed this technology to separate hydrogen from this byproduct gas coming from steel mill. And we were able to publish this article for the first time in the world. However, back then, even though we managed to separate hydrogen from byproduct gas, the efficacy of this model was not that high. So we used adaptive evolution and other measures to increase the productivity of hydrogen, and we made a lot of efforts to optimize the Na strain. So let me compare the microorganism that we discovered in 2002 and the one that we developed in 2016. So if you take a look, you can see a significant improvement in terms of specific productivity and volumetric productivity. It's more than 100 times higher. And as you can see from the video, the stability of biohydrogen production has also improved. we also made a lot of efforts for scaling up. In 2016, we completed the development of technology to produce 1 ton of biohydrogen in the Ansan campus of KIOST, and we also drew up plans to scale up this biohydrogen production. Back then, as I mentioned, we had a campus in Ansan, and Tangjin Steel Mill was relatively close from our campus. So we cooperated with Tangjin Steel Mill, and we created this biohydrogen pilot plant. So the byproduct gas coming from Tangjin Steel Mill will be used as a raw material, and it will go into the bioreactor and then the feed tank for hydrogen separation. And this was the model of biohydrogen pilot plant. So this is the picture of the biohydrogen pilot plant. And we were able to produce gas like this and put it into the bioreactor, which is a 1-ton plant, and then go into the PSA for hydrogen purification. And then using the fuel cell, we were able to produce electricity. And as a result, we were able to produce hydrogen continuously for 1 month using the byproduct gas coming from Tangjin Steel Mill. And the efficiency of conversion was 80% to maximum 90%. And we were able to separate pure hydrogen, and we also confirmed that this hydrogen that we produce can be used for automobiles and for other industrial purposes. And we were able to also confirm that using this biohydrogen, we can produce electricity. So our original plan was to use byproduct gas from steel mill to produce biohydrogen. So we completed the development of this technology using microorganism to produce biohydrogen. So from the pilot stage, we have scaled up to a demo plant scale, which is about 5 tons in capacity. And we are also using synthesized gas, and we are doing a pilot program to produce about 300 of NM3 of gas. So the demo plant looks like this, as you can see from the slide. This microorganism lives in the sea, so we created this ocean water storage and a hydrogen purification and utilization facility like this for biohydrogen production. In the long term, we are going to apply this technology in many industries. So we plan to supply carbon monoxide using the used heat from industrial complexes. And this is the research and development stage, the historical review on hydrogen production. In 2002, in deep sea, we were able to discover a microorganism that seemed at first irrelevant to hydrogen production. However, we were able to accumulate knowledge, and from 2009, we have been conducting research of using this microorganism for biohydrogen production. And one of our colleagues mentioned the Death Valley, but still we haven't been experiencing the Death Valley, and we are continuing to develop biohydrogen production technologies, and KIOST is leading this research. And PTS, which is a research institute established by KIOST, is preparing for the commercialization of this technology. This biohydrogen technology can be used to the government's efforts to achieve carbon neutrality. By 2030, we need to reduce greenhouse gas emission by 40%. And we also hope to contribute to that effort by developing biohydrogen production technologies like this. And taking this as an opportunity, I would like to thank the KIOST and the Ministry of Ocean and Fisheries, and also Mr. Kim, who is the president of KIOST, and also my colleagues in the research team, and also my overseas colleagues. I want to thank you, everyone. Thank you very much for